Hey everybody, this is Larry. This is day 27 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this one. Today I did my speed day on the track. Not that speedy, and very tired, and kind of did some shoulder work in the gym. Just kind of recover from a dislocated shoulder that I had last year. So just strong enough so that I could do a one-hand dead hang kind of thing, but I don't know, we'll see. Anyway, today I am passing out, so let's get started on today's problem. We have 2780 minimum index of a ratted cut or ratted split. Okay, so you have an element X, an integer array of length M, dominant if more than half the elements of array has a value of X. Okay, an element of X of an integer array of length M is dominant of more than half of the elements. Okay. Your zero index, you have nums with one dominant element. You can split nums into two indexes, okay? But the split is only valid if it is so basically both of them has at least one element and they're both dominant. Okay? So here we're trying to find a minimum index in which they're split. Here, for example, you may do 1, 2, 2, because what's the tiebreaker? What is dominant? More than half. Okay, so there's no tiebreakers because it has to be more than half. Okay, so in this case it's 1, 2, 2, and 2, so you have to do 2. Okay. Yeah, I mean, I think by definition, the dominant element has to have more than half, right? Because if you split it by 2, then, you know, there's no, there's a pigeonhole thing. So I guess the thing is just keeping track. Everything is just keeping track and bookkeeping as you go from left to right, right? So here maybe we will just do, well, if it's more than half, then you can use, is it Freud's selection algorithm or majority algorithm, or is it someone else? Or is it Dijkstra's maybe? I forget. Boiler Moore majority. Okay, today I'm having report, but this is going to be Boiler Moore's what is it called? A majority vote algorithm. That's what I said, but and I am just so tired. Maybe I should just sleep and do this in the morning. But yeah, I'm not gonna go over that right now, but it's this idea of if one element is more than 2, right? So this way you save space and stuff. I mean, because naively, or the straightforward way would be just to put everything in a hash table or something like that, keeping track of the count and just get the max. But of course that requires O of n space, so that's why we're not doing it that way. For now, anyway. Maybe we'll need to anyway, we'll see. But yeah, so then using this, we can just do 4x in nums. So we have, I'm trying to remember it off my head, but because the idea is just, yeah, so most common is you go to, say, none. And then count is going to be 0, right? And then for x, yeah, if most common is you go to x, then count increment by 1. Otherwise, count subtracted by 1. And then if count is less than 0, we said count is equal to 0, or maybe set to 1. I don't actually remember this. What common is equal to x. The idea here is just, and I'm trying to reconstruct the idea, like the code from the idea, which is that you basically have this, if you draw out the count as you go through the array, you'll see that it goes up and down. But once it goes down, what does that mean? What does count is equal to 0 mean, right? Count is equal to 0 means that at that prefix, the most common number is not the majority. It is exactly half the elements, right? But if it has more, then one of the element will always be true. Of course, it doesn't go through the other way, so that's why we have to go through the thing of, yeah, so now most common would contain the most common, so then we just track it a little bit, right? So maybe we count 0, 0, for x in nums, then this is just a straight up count, right? So if x is equal to most common, then count increment by 1, and then now we can check if count is greater than nums divided by 2. And of course, nums divided by 2, we can just multiply 2 on the other side. If this is true, or if this is not true, then we return -1, right? Because it's not possible, because you don't have a majority on one half, let alone both half. Otherwise, and maybe that stuff is not necessary, but still, this count gives us something, right? It means that here now we can say a sliding or a scan line algorithm, where basically you just split from the left side you have 0, and then count you have, oh sorry, right side you have count. So here it is just a sweep line, right, where you divide from the 0th index. So not a valid index because you need at least one element, but 0th index, this is what it looks like, right? So then now for x in nums again, so here left is the number on the left side, which is most common, right? And same for the right side, and that's why. And then here, if x is equal to most common, then that means that it went from the right side to the left side. So then left increment by 1, right subtract by 1, right? And that's mostly it. I think the two things that I want to do, one is that we don't want to count the last element because you never want to move the last element to the left side. So maybe we can do this, so you skip the last element. Another thing is just maybe keep track of the index. And this part you can actually do a number of ways, but I'm going to do it this way. And the reason is just because it is both an index, but also the number of numbers that are on the left side, right? Because if you're at index 0, that means, and after you do this, that means that now index 0 is where you cut off, right? Where you have this, what do they call it? A split, right? So then now, yeah, both the split of the index and also whether it's dominant on the left side, right? Because here, if the index is say 2, that means that the 3 numbers on the left, and then you could do the math that way, right? So that means that if left is times divided by if left is greater than index plus 1 divided by 2, right? So yeah, that means that it's good. Of course, just for not dealing with fractions, we get times 2 on this side, right? And on the right side, the same thing. Right is greater than, how many elements are there, right? Oh, I didn't pick n. N is equal to the length, right? On the right side, we have n minus index minus 1, I think, right? Because if index is the last number, which we can anyway, but index is the last number, this would be 0 elements, which is right. So yeah, right? So this over 2, which again we multiply by 2 on this side, and if that's good, then we return index. At the end, we can return -1, right? Maybe I'm off by 1, but hopefully this should be good. And of course, oh, this is n. I don't know why I wrote this way. Maybe I meant length of n. But yeah, looks okay for here. Still way easy to make off by 1s, but let's give it a submit because I'm tired. All right, well, tired Larry is happy. But that is the entire code. Let me make it slightly smaller, maybe even slightly smaller. I think you need this, but maybe, I mean, it's, well, you need to do the count for here anyway, so it's fine. You might not need this because if you don't have this, then this just never be true. But yeah, this is all of n time, all of 1 space, which is the important thing. So maybe this slice is a little bit weird. We can just skip the last element anyway. But yeah. That is all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye bye.